Hey guys, today we're going to solve the unique binary search trees problem on LeetCode. The problem description is we're given an integer n, and we need to generate all structurally unique binary search trees that store the values 1 through n. Here's the example given. They give us 3, and here's the output is these 5 trees. Okay, so anytime you're given a problem where you need to generate a set of some things, recursion is usually going to be a good way to do it. If you try to come up with iterative approaches to this, it can be pretty difficult. So let's just run through the code of how we'll do this. So up here's the function that LeetCode gives you. Just generate trees given n. Now if n's less than 1, then there's none. So we just return a new array list. Else, we have this function that I wrote, this helper function, generate trees 1 to n. Okay? So let's look at what that function does. So we initialize our answer as a new array list, and we're given low and high, basically the integers that are going to be stored in this tree. If low is greater than high, that means there are no elements in this tree. We add null to show that there's just an empty tree here, and we return that. If it's not, then what do? Then we loop from low to high, and basically for each value in that range it becomes the root of the tree. Okay, and what we do is we recursively solve its left and right subtrees. So everything, since it's a binary search tree, for a root I, everything in its left subtree will have to be less than it, so that will be in the range low to I minus 1. And then everything in its right subtree will have to be greater than it. So we generate trees for its right subtree in the range I plus 1 to high. Okay, so these two calls, after these, for a root I, for a root with value I, we have all the left subtrees of it and all the right subtrees of it. So then all we have to do is loop through those trees, and for each combination, make I the root, and then set its left to be the left subtree and its right to be the right subtree, and then add that to our answer. And that's exactly what we do here. And then out here we just return answer. Alright, so it works. Cool. So again, if you see a problem and it says generate all these things, coming up with binary search trees, combinations, permutations, whatever it is, recursion's usually the best way to go. And you're sort of going to build it as you go here. And we went through that pretty quickly, so once again, just kind of an overview of this generate trees function. It takes in a low and a high, and what this function returns is all structurally unique binary search trees, storing the values from low to high. Okay? If low is greater than high, there's no values, so we just add a null tree to show that that's an empty tree, and then we return that. And then what we do, for each value in low to high, we make that value a root, and then we recursively solve all the subtrees that could be its left subtree, all the subtrees that could be its right subtree. And then for all the combinations of those, we make I the root, and then set its left to be the left subtree, right to be the right subtree, and then add that. So pretty quick, simple explanation. Just this is all the code you need right here, so if it's not terribly clear, just take a second to look through it, see exactly what's going on here, and really understand these recursive calls, what they're doing.